All right, so we had in lesson chapter 2, section 4, we had where we had to find the zeros in the linear factors, but now they're telling us to go backwards. They're giving us the zeros, and they're telling us to find a fourth degree. Well, I only have 3 zeros, but because of the complex conjugate theory, I know that if I have a positive 2i, I also need a negative 2i. So we're actually just looking for a fourth degree polynomial function with real coefficients of -2, -2, and 2i. So since I was given that 2i, the complex conjugate theorem tells me that I'm also going to have a negative 2i. From here, I'm going to use x squared minus the sum of x plus the product. When I add these, I get 0. When I multiply them, I get negative 4i squared. Remember that I squared is equal to -1. So this, a -2, as a linear factor would be x plus 2. This would also be an x plus 2. Or you could use that pattern again. You could use this x squared plus the sum of x. And I know right here with my 2 imaginary numbers, I have x squared plus 4. So we just have to FOIL this all the way through. I know these 2 FOILed will be x squared plus 4x plus 4, and I'm sure you're just as good at FOILing those as I am. And now we have to go ahead and multiply this. Sorry, my notes are too small. I need to make bigger notes. X squared going through all 3, 1, 2, 3, is x to the 4th plus 4x cubed plus 4x squared. And when I put 4 through 1, 2, 3, I like to line it up 4x squared plus 16x plus 16. And when I add these together, I get my fourth degree polynomial. I'm going to write it over here. Hopefully you could still see it. As f of x equals x to the 4th plus 4x cubed. I'm going to add these two, plus 8x squared plus 16x plus 16. Good job. We've been doing quite a few of these in class, and the last question that I'm going to go over in chapter 2, section 4 is this. Find all the zeros of this fourth degree polynomial given that 1 plus 3 is a 0. Well, we just talked about the complex conjugate theorem. If 1 plus 3 is a 0, I also know that 1 minus 3i is a 0. And we talked about this little formula. If you don't know this by now, I would highly, highly recommend. It's something I taught you guys in Algebra 2. I would use this. It's so much easier than the way other people do it. So when I add these together, I get 2. When I multiply, I'm just going to show that FOILing. Remember, the inners and outers cancel out. 1 times 1 is 1. The outers are negative 3i. The inners are positive 3i. And my last terms are negative 9i squared, which is a -1. These cancel out. So when I add, I get 10. Whew. Now, this is the part that you really hate. You are in pre-calculus. You have no choice but to do this. We have to take this trinomial that we just found, x squared minus 2x plus 10, and we have to use long division and put it into this fourth degree to see what happens. I'm going to do this, so I'm going to turn off the recording and do it. So when you see this, if you don't push pause and do it yourself, you will have the answer right there. All right, so I used long division. I took the trinomial that I got from using that Algebra 2 formula right here, and I use long division to put it into my fourth degree. And I end up getting x squared minus x minus 6. Well, fortunately, this factor is very pretty for us. So this can factor to be x minus 3, x plus 2. When I make them each equal to 0, the 0 that comes out of this is 3. The 0 that comes out of this is negative 2. So it says to find all the zeros. One of the zeros was given to us. From there, I know that the other 0 is going to be the complex conjugate, which is 1 minus 3i. And then from using a long division and finding, I could find the other 2. So I'm going to write the 1 plus 3i here as well. That was given. But remember, it is a fourth exponent, and I have 1, 2, 3, 4 zeros.